All right, we are starting Lesson 2. This is going to be screencast number 1 for Unit 4, Lesson 2, and this lesson is about balanced and unbalanced forces. I'm on page 186, and I'm looking at the essential question, how do forces affect motion? By the end of this lesson, you should be able to compare different types of forces and show how unbalanced forces affect an object's motion. So let's get started. All right, I am on page 188 now. I'm not going to read everything, but I'm going to hit the highlights. Under the blue title, what is a force? Look down a couple of sentences and it says a force is a push or pull that acts on an object. Forces can be measured. The SI unit of measurement for a force is a Newton, named after Sir Isaac Newton. A spring scale can be used to measure the force of a pull in newtons. Okay? A spring scale often measures weight, which is the amount of pull that gravity exerts on an object. There's your definition for weight. Okay? Second blue heading, how do forces act on objects? Force is a vector quantity. Remember that vector quantities have both a size and a direction. So, therefore, a force can make an object move or change direction. It can speed up an object, slow it down, or stop objects altogether. Okay? We're going to be using arrows to show the direction of a force, just like we use arrows to show velocity. The size of the arrow is going to show you how big the number or the magnitude is, and the direction of the arrow is going to show you which way it's acting. Okay? The big concept here is that forces cause acceleration. Really, when we get specific, it's unbalanced forces that cause acceleration. Okay? Balanced forces do not cause acceleration. Well, Ms. Goff, what is balanced and unbalanced forces? What are you talking about? We'll get to that on page 190. Okay? Let's look at page 189. I'm under the red heading that says some forces act through direct contact. Okay? Forces that act through direct contact are things like applied forces, which involve direct contact with an object. When you take a book and you touch it and you grab it and you lift it up, that's an applied force and you're in direct contact with the object that you're moving. Friction is another applied force. Okay, friction is a force that opposes the motion between two surfaces that are in contact. Important thing about friction. Friction is a force that always acts against motion, causing an object to slow down and eventually stop it, unless there's a constant force to overcome friction. Okay? For instance, if you are in a car, your cruise control will provide the force from the engine to keep your car going forward, or you can keep your foot on the gas pedal. But if you take your foot off the gas pedal, your car's going to slow down, and that's because of the friction between the tires and the road, and the friction between the air and your car, that kind of thing. Okay, friction always acts against motion. Now, there are some forces that are capable of acting over a distance, meaning that objects don't have to be in direct contact. So I'm now on the second red heading where it says some forces act at a distance. Gravity is a great example. Gravity is a force that can act through empty space. Okay? Gravity is the universal attraction that exists between objects. You may not know a whole lot about gravity, but the amount of gravitational attraction depends on the masses of the objects that are involved and how far away they are from one another. Okay? Remember that weight is a measure of the force of gravity acting on an object. We've already stated that. Magnetism is another force that can act over a distance. Okay, magnetism between two metals that are capable of exerting magnetism. Okay, those are two non-contact forces. All right, so let me show you what I have on these two pages and let you get caught up. Okay, notice on page 188, I've given you a definition for weight, but it's also defined in two different places on these two pages. So weight's a type of force. It's the force of gravity on a certain mass or on a certain object. Okay. If I wanted to calculate weight, weight is equal to mass times acceleration due to gravity, which we usually represent by the letter G. I underlined the definition of force. I underlined that the SI unit of measurement for force is the Newton. And I underlined that a spring scale can be used to measure force. Okay. I also made a note of the fact that forces cause acceleration. Not just any force, but unbalanced forces cause acceleration. Okay. On page 189, I underlined that applied forces involve direct contact with an object. Like if you push on something, you're in contact with that. That is an applied force. Friction is an applied force because it acts on an object when two surfaces are in contact. And remember, I made a note, and this is really important. If it's important enough for me to write down, it's an important enough thing for you to write down. Friction always acts against motion, causing objects to slow down and stop. Okay. There are other forces capable of acting over a distance. Gravity and magnetism are probably the two easiest examples. And once again, it does remind you what weight is. Weight is the measure of force of gravity acting on an object.